So after abstract classes, it's time to talk about interfaces. Here you can find out what the color coding will mean. So if it's yellow, it means that it's a required modifier. If it's orange, then it's implicit. White is just normal code, the names that you give to a function, class, etc. And the blue is usually the type or the return type. Here I start the interface declaration. Abstract is already implicit. And when I say it's implicit, it means that you don't have to add this word and it's going to be inserted by the compiler. After that, I try to show you all the types of variables and methods that you can put into the body of an interface. So when you create a variable in an interface, it's going to be implicitly public, static, and final. Here I'm creating an integer, and it's named max, and this here is an abstract method, and this is the primary use of interfaces, at least it has been, its basic use, and the reason why I have this dashed line underneath is because these methods that have bodies were added later on. And there is the default method, the static method, private method, and private static methods. The default and the static method are implicitly public, but the rest of them have certain requirements. If we go to the side here, I also gave them this type column. And to better understand that, maybe we should come down here. So when you have an interface, it still has this distinction between class type and instance type. So when it's a class type method or variable in an interface, it is shared among all the instances. But when it is an instance type, it's just part of one instance. Interfaces don't actually have instances, or maybe it's more accurate to say that the instance of an interface is a concrete class which implements the interface. So the instance methods apply when a class implements the interface. And here in the table you can see that whenever the variable or the method is static, it can only be related to the class level. Here, there, and there. We have certain rules here. The protected and package modifiers are not supported by interfaces whatsoever. You can use them in abstract classes, but you can't use them in interfaces. So if the method is not private, the compiler will implicitly add the public. If the method is not abstract and it has no body, then it's going to add abstract and public. If it's already public, we do nothing. If you were to try to create a package access method, then implicitly public would be added, so it would become public. If you were to try to add the protected modifier, then it would just throw a compile error. Here we have a few more rules. So classes can implement an unlimited amount of interfaces. They cannot extend them, because classes extend each other. A class can only extend a class. However, an interface can extend multiple interfaces. One class cannot extend a list of other classes because multiple inheritance is not supported in Java. But interfaces are abstract types. They have no instances. They don't follow the normal class inheritance, so that's why they can extend multiple other interfaces. Adding methods are actually optional in interfaces, so you can even have an empty interface. An interface cannot be final because the whole reason for an interface is inheritance. It also doesn't have a constructor as opposed to an abstract class. Okay, there's one more. So let's say we have interface A and it has an abstract method which should return string. It's called foo. We also have interface B, and it has the same function with the same signature. So let's say that our class implements A and B. And now, of course, our class is required to implement both of these abstract methods, but it can do so in only one line because the signature is the same. However, if the return type of these two foo methods are incompatible, let's say this one was int, we would get a compile error. So let's talk about this newer addition, the default method. It's an instance type. So whenever you have a default method, it has a body and it can be overridden. You don't have to. And it also cannot be final because it makes no sense. Default methods don't require an implementation, but they are still instance types and they are meant to be inherited. So that's why they can be final. But what happens when we have two different interfaces with two default methods that have the same signature? That's a special case. In that case, you must override the method. So let's check. We have interface A, we have interface B. They both have a default void foo method, but they return something different. The same disclaimer applies here. If their return type weren't compatible, we would get a compile error. Our class implements A and B. Normally overriding a default method would be optional, but since the methods of these interfaces have the same signature, there is this extra rule where the class must override the method. So this is what we do here. We say hello, and everything is fine. But now you might be asking, what if I want A's foo function? Or what if I want B's foo function? What if I just want to say hi or hey instead of making my own implementation? Can't I just call this somehow? And the answer is yes, you can. You absolutely can. However, there is this very strange syntax for it. So you have your public void foo and you just say a.super.foo. And that looks very weird. And when I first read about this, I was just stunned. I read the explanation, I couldn't understand what was going on, and even now I don't think that explanation really works for me, because it says that the default methods have the properties of both static and instance methods, which I guess it kind of makes sense, but I found a better explanation for myself. I don't mean to tell the authors how to explain this to me, I'm just trying to find my bearings here somehow. So let's say you are building this language and you just want to find a way to call A's foo method. A is static related, super is instance related. Let's say we try to use A. If I say a.foo, that's not going to work, because that would be a static call. Yet our default method is instance type. We cannot just call it in a static way. If we had a static method in the A interface, then that's how you would call it. This is already taken. We can't even use this. So the question is how to make this instance related. Let's check the other side. If we use super.foo, that's also not good enough. Why? It goes back to the rule or the notion that a class can implement multiple interfaces. So how can you differentiate between them? One super call is not going to be enough. I say super, okay, which one? A or B or C or who knows what? So that's when we come to this point. We combo them. We put them together and say a.super.foo. And this is a function call, but let me do that. Okay, so let me demonstrate this to you. We have a class here called C. We have two interfaces here, A and B. Interface A has the foo method, it returns hi. B also has the foo method and it returns hey. So when C implements these interfaces, it has to provide an implementation for the foo method. It does so, and in the main method, we just create a new instance of C and we print out the foo. It should write hello to us. Let's check that. That's it. Great. Now let's just use what we have learned here and print out A's foo method, which is hi. So I can just change the implementation here. So let's return a.super.foo. Let's check it. And it says hi. Good. Okay, let's try B. It should say hey. And it says hey. Great. Fantastic.